Okay, in this lesson we're going to talk about slope. So I've been training for the half marathon and I've been practicing my speed work in the 1 mile run. And every 4 weeks I run a 1 mile time trial. They actually time me. And I plotted the results below. So let's find the slope of the line and interpret it as a rate of change. So let's look at the graph for a moment. So we have the time in minutes labeled here on the y-axis. That's my time. So at the very beginning, the number of weeks since training began is the x-axis. So right at the beginning, at 0 weeks, my initial time trial was right there at 8.5. And then after 4 weeks, I go down to 8. After 8 weeks, I'm here at 7.5. And you kind of have to fill in these right here, right? Because there's 7, there's 7.5. And we want to find slope and interpret what does this slope mean as a rate of change. Let's make this graph a little bit bigger. Okay, so let's pick any 2 points on here. Let's pick this first point here, and notice we have here, this would be 9, it didn't fill it in. And so right in between 8 and 9 is 8.5. So there's 8.5. Similar over here. So there's 6 to 8, so there's 7, and there's 7.5. Okay, so here's 1 point. Let's go down till we get to this point right here. So if I go down here, then over. So here I went down from 8.5 to 7.5, which means I went down 1, right? And over how many? Over 8. Because I went from 0 to 8. It won't always be this number here on the x-axis. But I went from 0 to 8, which is 8. So remember my slope is the change in y, and we use delta for change in, over change in x. So the change in y was down 1, so we indicate down with a negative, over change in x, which was 8. So my slope here is -1 over 8. Now I could have picked any points on here. This one here would have given me a fraction. I would have gone down 1/2 over 4. You still get -1/8, but it involves having to reciprocate and multiply a couple fractions, and that gets a little tricky. Avoid that when I can. Okay, so here's our slope. But really the more important part of this is, what does this slope tell me? So think about it for a minute, what this slope tells me. It tells me that my time in the 1 mile run decreases 1 minute. So it decreases my time. I don't have to write all this, so it decreases 1 minute every 8 weeks. So that's one way to look at it. Another way, and slopes are often not expressed as fractions, but rather as in decimal form. So if you wrote 1/8 as a decimal, this would be equal to 0.125 negative. And so I could interpret it as I actually drop about -0.125, we're still in minutes, per week. This is over 1 now, right? We could convert this. What is 0.125 of a minute? We don't typically talk like that, right? We don't say 0.125 of a minute. If I multiply that by 60 seconds that are in a minute, I end up getting 7.5 seconds. So my time would decrease 7.5 seconds per week. Okay. So another way to write that is my time decreases about 7.5 seconds per week, or 1 minute every 8 weeks. Depends on how you look at it. They're both fine. We're not always given a graph, though. We'll do a few more with a graph just to give you a better notion of what the slope is measuring, but often we're just given 2 points. So I don't want to have to necessarily graph these, particularly if I get decimal points or really big points. It becomes impractical to graph them and find the slope, and also if they don't happen to cross on nice little grid points. So let's derive our slope formula here. So let's say I've got a line here, 2 points. We'll just call one point x1, y1, the next point x2, y2. Doesn't matter which one you call x2, y2, or x1, y1. So my slope again is delta y over delta x. So my delta x, my change in x, I just subtract the two x's, x2 minus x1. And delta y, very similar, I subtract the y's. So my slope, delta y over delta x, I'm just going to replace that with what delta y is. What is delta y? It's the change in y. I just subtract my two y's, subtract the two x's. In this particular example, I've got numbers there. You could think of it that way if you wanted to. 6 minus 4 would be my delta y. And you get 6 minus 4 up in the top, and then 7 minus 3 or 4 in the denominator. And then you can simplify that. Let's look at some examples. So if we find the slope from a graph here. So you find 2 points. Doesn't matter which points you are, but pick ones that are on a grid. I would not have wanted to choose, for instance, this point here, so I didn't really know what that is. I go down 3, so I put a minus 3, that's change in 3, and then over 4. So this is the way to do it from looking at the graph. So again, let's do this one. We find 2 points. Let's relate this to this formula, though. We don't care which one, again, is 1 and which one you call point 2. So there's our formula, y2 minus y1 divided by x2 minus x1. Identify your points. There's our first point, 0, 2. We can label that x1, y1. Next point, 1, 4. We can label that x2, y2. We could have flip-flopped that as well. It doesn't really matter. Now let's plug these into the formula. So y2 minus y1, we're going to have 4 minus 2, and then x2 minus x1, 1 minus 0. It's really worth it to label it. Make sure you put these labels. It just sort of removes a layer of thinking you have to do. Now let's do the arithmetic. 2 over 1, and you get a slope of 2. So we could have done this using just a graphical approach, right? The change in y over change in x. Again, identify your 2 points. I'm going to go over 1, up 2. Slope is delta y over delta x. We get 2 over 1, which is 2. The same thing we got when we use the formula. But again, you're not always going to be given a nice, neat graph. So I want you to see how the formula related to the graph. So find the slope of the line below. And I'll pause the video here, see if you can do this one. All right, welcome back. And let's use the formula for this one. Whenever I use a formula, even if I already know it, I write it down. I might not always do that for you guys, but it's good practice to get into. I sometimes don't have room on the screen here. So the slope is y2 minus y1 over x2 minus x1. Identify 2 points. Here's a good looking point here, and my next good looking one is right here. So this point here is going to be 0, comma, negative 2. You can label that one x1, y1. I normally label mine left to right. Doesn't really matter though. This next point is going to be 4, comma 1. Call that x2, y2. So now let's plug it in. And again, this is a y here. Doesn't look like x1, y1. So y2 minus y1. So 1 minus negative 2 over x2 minus x1. 4 minus 0. Plus a positive, we're going to get 1 plus 2 is 3 over 4. Now notice this slope is positive. So just to summarize, we've seen a few of these before. So if my line is doing this number right here, is x increases, y decreases, my slope is negative. If my line increases, so as x increases, y increases, my slope is positive. Just keep that in mind. The mathematics will fall out, but it is certainly nice to know which ones are negative slopes and what positive slopes look like. Example 4, find the slope of the line below. Pause the video here, see if you can do one. All right, welcome back. Label your 2 points. There's a good looking point there, and here's another good one. So this first point is 0, comma 1. Next point here is 3, comma negative 1. Label x1, y1, x2, y2. So y2 minus y1 over x2 minus x1. I know that formula, but write it down. It makes your work look neater. It allows you to follow things more closely. So negative 1 minus 1 all over x2 minus x1, 3 minus 0. Do the arithmetic plus a negative. We're going to get negative 2 over 3. And you can certainly do the down 2 over 3. And that is definitely easier when they are graphed like this. But again, in a few minutes, we're not going to have them already graphed. Like this one. Find the slope of the line containing the points 0, negative 1, and negative 5, 3. Pause the video here. Work this one out. Just use your formula. All right, welcome back. So there's our formula. y2 minus y1 over x2 minus x1. Label x1, y1, x2, y2. And then plug it in. 3 minus negative 1 divided by negative 5 minus 0. Plus a positive, we're going to get 4 over negative 5. And we'll often bring that negative up to negative 4/5, to where it's in the numerator or right up to the side. Either one's fine. I kind of prefer this one though. Negative 4/5. Okay, find the slope of the line containing the points 3, 4, and negative 2, 1. Write your formula down, and then plug in. x1, y1, x2, y2. So 1 minus 4 divided by negative 2 minus 3. So we get negative 3 over, or plus a negative, negative 5. 2 negatives give me the positive, and I get 3/5. A couple more. Find the slope of the line containing the points negative 2, 6 and 5, 6. Okay, welcome back. I know you paused it there. Got to work on these on your own. But something weird happens on this one, or something a little different. Let's label these. I'll label below. x1, y1, x2, y2. Let's plug them in. So 6 minus 6 divided by 5 minus negative 2. So 6 minus 6 is 0 over 5 minus negative 2 is 5. Plus a positive 2 is 7, which is 0. Now that's not completely crazy, right? 0 is a perfectly fine number, but I'd be interested to know what kind of lines have a slope of 0. So I plot it out. Let's see what kind of lines have a slope of 0. So we have negative 2, 6, call that 6, 1 point, and over 5, call that 5, up 6. And let's pretend this is this nice straight line. Horizontal lines have a slope of 0. That's something to keep in mind. So horizontal lines, slope is 0. If the slope is 0, it is a horizontal line. That's important. Okay, find the slope of the line containing the points 3, negative 4, and 3, 5. Okay, we got our formula. What happens on this one? Let's label x1, y1, x2, y2. So 5 minus negative 4 divided by 3 minus 3. Uh-oh. What's going to happen here? We get 9 on the top, no problem there. 3 minus 3 is 0. And what do we know about 9 divided by 0? We can't do it, right? This is undefined. Well, whenever something kind of weird looks at, I'll just put undefined and move on when you're first learning something. What kind of lines have an undefined slope? I'd be interested to know that. It's kind of odd, right? So let's plot that out. Let's investigate this. So x equals 3, y is negative 4. We'll call that negative 4. Call that 3. Not to scale. And then 3, 5. I see what kind of line. Nice little vertical line. Pretend that is a straight line. Vertical lines have undefined slopes. That's important to know. If the slope is undefined, it must be a vertical line. If it's a vertical line, it has an undefined slope. Okay, a couple of applications we're going to look at here are grade and pitch. So, never been to Hawaii, not yet anyway, as of the filming of this video, but there's a 25% grade over 0.7 miles in Hawaii. Pretty steep grade. I know you guys have seen these steep grade signs around. And pitch or slope of a roof. A couple of problems we can look at. So here's another sort of a pitch problem. Find the grade of a handicap ramp if it rises 4 feet over a horizontal distance of 18 feet. So let's go ahead and draw a diagram out here. Maybe you'll do this without me helping you. So pause the video here, give yourself some credit, try to find the grade of this handicap ramp. Okay, welcome back. Let's just draw this out, change the perspective a little bit. And it rises 4 feet over a horizontal distance of 18 feet. We want to know the grade of that. So again, my slope is the grade, is change in y over change in x. Sometimes when working with sort of geometric shapes, this change in y is my vertical change. And the change in x is the horizontal change. So that might make it easier for you to think about. So in this case, my change in y is 4. We'll leave the units off for now. Change in the horizontal distance is 18. These are often expressed, let's reduce fraction to 2/9, but often they are expressed as decimals, so 0.222. It keeps repeating, and sometimes expressed as a percent, as we saw in that grade sign. So 22% grade. Sometimes they'll express it as a 2 to 9. 22.2% grade. Take it out to one more decimal place. Okay, last problem here. Suppose the span of a roof is 24 feet across and has a 10-foot rise. Find the pitch of the roof pictured below. And I've given you sort of a link there if you wanted to click on that. Okay, let's redraw the part we care about. Here's our roof. And we have 24 feet across. And it rises 10 feet. So what is the pitch of this roof? So it's 24 feet across. That means this little part here is 12. So my slope's going to be my change in y, or my vertical change, 10, over my change in x, or my horizontal, 12. Which reduces to 5/6, and you can get a decimal for that at about 0.83. I don't think you normally express because of roofs as percents, but I would take either one of them.